So today I'll be going over 4.3 and 4.5, which is solved by factoring. So first, some vocab. Roots and zeros are just another name for the x-intercepts. So when it asks you to solve for the roots, or find the roots or find the zeros, that just means find the x-intercepts. Okay, so there are two different special cases for factoring. There's difference of two squares or dots. So if you have a squared minus b squared, that'll equal a plus b times a minus b. So you'll have two terms, and both of them are a perfect square. So for example, if you have x squared minus 9, that would equal x plus 3 times x minus 3, because the square root of x squared is x and the square root of 9 is 3. The other one is perfect square trinomials, so you can also call this PST. This would be a squared plus 2ab plus b squared. That's going to factor into a plus b squared. And there's also a squared minus 2ab plus b squared, and that'll factor into a minus b squared. So an example would be x squared plus 4x plus 4. That's going to factor into x plus 2 squared. And another one would be 4x squared plus 20x plus 25. And that would factor into 2x plus 5 squared. So the square root of 4x squared is 2x. That's this part here. And the square root of 25 is 5. Okay, but if they're not one of these two special cases, then you'll want to factor using the x method. So for the x method, first you'll want to make sure that the equation is in standard form, and you want to factor out the GCF first. So we'll first do sum where a is 1. So standard form is ax squared plus bx plus c. And for the x method, you would draw an x. And on the top, you're going to multiply a times c, and you want the two numbers to multiply to this number. And on the bottom would be b, and you want it to add to this number. So, for example, if we have x squared plus 3x plus 2, so first we're going to draw our x. And on the top, we want to multiply a and c. So I'm going to call, or I'll just write the letters on the top. So a would be 1, b would be 3, and c would be 2. So a times c would be 1 times 2, which is 2, and b is 3. So we want to find two numbers that will multiply to 2 and add to 3. So that would be 2 and 1. And what I do is just write an x on the top, since x times x will equal x squared. So then this will factor into x plus 2 times x plus 1. So you kind of just take those fractions and write it as a term. Okay, now when a is not 1, it's going to be similar steps, but there's one extra step. So for example, if we have 2x squared plus 5x plus 2, so we're going to do the same thing, draw an x. On the top, again, will be a times c. So in this one, a is 2, b is 5, and c is 2. So a times c would be 2 times 2, which is 4, and b is 5. So we want to find two numbers that multiply to 4 and add to 5. So that would be 4 and 1. And then I'm going to write a times x on the top of these. So that would be 2x over both of them. So we kind of have this fraction, 2x over 4 and 2x over 1. And if you can simplify it, you want to do that first. So for this one, we can simplify this to x over 2. And the bottom one, we can't, so we can leave it. And that'll become x plus 2 times 2x plus 1. So these would be the factored forms. Okay, So let's do some examples. Let's say we have to factor x squared minus 7x plus 10. So first we'll draw our x. A is going to equal 1, b equals negative 7, and c equals 10. So for this one, 10 would go on top and negative 7 would go on bottom. So we want to find two numbers that will multiply to positive 10 and add to negative 7, and that's negative 5 and negative 2. And we're going to write x on top. So this will factor into x minus 5 times x minus 2. And the order that you write these answers don't matter. So you could have x minus 2 times x minus 5. Okay, for this next one, we're going to do the same thing. Draw our x. On the top is going to be negative 36, and on the bottom is going to be 9. So we want to find two numbers that will multiply to negative 36 and add to 9, and that would be 3 and negative 12. And again, we're going to put our x on top. So that becomes x plus 3 times x minus 12. Okay, next we have x squared minus 81. So whenever there are two terms, that's usually going to be a difference of two squares. So if it helps, you can write what a and b are. So a is going to be the square root of the first term, so square root of x squared is x, and b will be the square root of the second term, and square root of 81 is 9. So this would be x plus 9 times x minus 9. And this is by using dots. Okay, this next one. Oh, and also you can, like if you don't remember that this is a difference of two squares, you can still use the x method. On the top would be negative 81, and the bottom would actually be 0 because there's no b term. So we want to find two numbers that multiply into negative 81 and add to 0, so that'll be negative 9 and 9. So you'll get the same answer. Okay, then for this one, again, you can do the x method again, or you can, or if you realize this is perfect square trinomial, or PST. So, hold on, I'm going to rewrite that in blue just to stay consistent. Okay, so for this one, a would be the square root of 16x squared, which is 4x, and b would be the square root of the last term, which is 1, and square root of 1 is 1. So you just want to check that the middle term is actually plus 2ab or minus 2ab. So 2ab would be 8x, right? And we have 8x here. So that means it is a perfect square trinomial. So this would be 4x plus 1 squared. Okay, so let me just go over one where it's not PST. If you look at this one, even though the first number is a perfect squared, x squared is a perfect squared, and 36 is also a perfect squared, this is not a perfect square trinomial because first it's not plus 36 at the end, and the middle term isn't 2ab. So if we found a and b, a would be x and b would be 6, and the middle term isn't 12 or negative 12, so that's why it's not a perfect square trinomial. So that's why we can't use that equation. Okay, next we have 12x squared minus 4x minus 40. So the very first step is to always factor out the GCF. The other ones didn't have any, but for this we can factor out a 4. So that'll be 3x squared minus x minus 10. And when we do the x method, we're only going to do the part that's inside the parentheses. So on the top would be negative 30, and on the bottom would be negative 1. So our numbers would be negative 6 and 5. And on top would be a times x. So in this case, a is now 3. So it would be 3x on both. Okay, so 3x over negative 6, that would simplify to x over negative 2. So that becomes x minus 2. And 3x over 5, that doesn't simplify, so that'll be 3x plus 5. And you don't want to forget about the 4 in the front. So our final answer would be 4 times x minus 2 times 3x plus 5. So whatever GCF you factor out, you'll just carry it into your final answer. Okay, next one. The GCF of this one is also 4, so we want to factor that out first. So that'll be 4 times 2x squared plus 7x minus 15. On the top is going to be negative 30, and on the bottom is going to be 7. So the two numbers that multiply to negative 30 and add to 7 are 10 and negative 3. We're going to write 2x on top. So 2x over 10 would simplify to x over 5. So that becomes x plus 5. And 2x over negative 3 doesn't simplify, so that just becomes 2x minus 3. So the final answer would be 4 times x plus 5 times 2x minus 3. Okay, so that's how you factor. In the next section, we're going to solve. So the solving problems will always have an equal sign. That's how you can tell the difference. And the first step is to rewrite everything into standard form first. So this first one is already in standard form. You always want it to equal 0. So we're going to factor. On the top would be 12 and on the bottom would be negative 8. So we're looking for two numbers that'll multiply to 12 and add to negative 8. So that'll be negative 6 and negative 2. We have our x on top. So that's x minus 6 times x minus 2 equals 0. So now to solve, we're going to set each part equal to 0, because if one of them equals 0, then the whole thing will equal 0. So if x minus 6 equals 0, then the entire thing will equal 0 because we have 0 times x minus 2. Or if x minus 2 equals 0, then the whole thing will equal 0 there as well. So we're going to add 6, and we get x equals 6. And on the other one, we're going to add 2. So the answers would be 6 and 2. Okay, for the next one, I'm going to move everything to the right just because I want to make sure that a is positive. So I'm going to subtract 14x and add 49. Okay, so this becomes x squared minus 14x plus 49 equals 0. And this is actually a perfect square trinomial. So this would become x minus 7 squared equals 0. So that just means x minus 7 times x minus 7, so I only have to solve it once. So I would set it up as x minus 7 equals 0, and then add 7 to both sides, and I get x equals 7. Okay, next one. We have 14x squared minus 21x equals 0. So I will want to factor out the GCF, and for this problem, that would be 7x. So I'll be left with 2x minus 3. And outside of the GCF, there's no way to factor more because there's no more x squareds. So we're going to set this part equal to 0 and this part equal to 0. So 7x equals 0 and 2x minus 3 equals 0. So for the first one, we would divide by 7 and we get x equals 0. And for the second one, we would add 3. So we get 2x equals 3 and then divide by 2. So x equals 3 over 2. So those would be the two answers for this problem. Okay, next one. I'm going to move the x over. So we get 4x squared minus 16x equals 0. And we have to factor out the GCF first, which is 4x. So we're left with x minus 4 equals 0. And now we're just going to set each one equal to 0. So 4x equals 0 and x minus 4 equals 0. Then to solve, we're going to divide by 4. So we get x equals 0. And on the other side, we're going to add 4. So we get x equals 4. So the final answer would be 0 and 4. Okay, the next section, we're going to find the zeros of the functions by rewriting the function in intercept form. So we first want to rewrite into intercept form, and then we're going to solve, which is what we did in the previous examples. Okay, so that means we'll want to factor. So for this, you would have negative 45 on top and negative 12 on the bottom. So we want to find two numbers that multiply to negative 45 and add to negative 12, and that would be negative 15 and 3. And we're going to write x on top. So in intercept form, this would be x minus 15 times x plus 3. But to solve or to find the zeros, we have to set it equal to 0. So that would be x minus 15 equals 0 and x plus 3 equals 0. So then we're going to add 15 and we get x equals 15. And for the other side, we're going to subtract 3, so we get negative 3. So the zeros would be 15 and negative 3. And if you want to write this as a point, it would be 15, 0 or negative 3, 0. Okay, next one. We have g of x equals x squared plus 22x plus 121. This is a perfect square trinomial, so this will factor into x plus 11 squared. Or you could also write it as g of x equals x plus 11 times x plus 11. Either one is fine. But this second one is more like intercept form. Okay, so to find the zeros, we're going to set it equal to 0. So we really just have one equation, x plus 11 equals 0, since they're both the same. So we're going to subtract 11, and we get x equals negative 11. And as a point, that would be negative 11, 0, since this is the x-intercept. Okay, next one, we have f of x equals 3x squared minus 8x plus 5. So first we want to factor. So on the top would be 15, on the bottom is negative 8. We want to find two numbers that multiply to negative 15 and add to negative 8, so that's negative 5 and negative 3. And on the top we're going to write 3x. So for 3x over negative 5, that's going to become 3x minus 5 because it doesn't simplify. And for 3x over negative 3, that would become x over negative 1, which becomes x minus 1, since it does simplify. So that means we have 3x minus 5 times x minus 1, and that's factored form. Then to solve, we're going to set it equal to 0. So 3x minus 5 equals 0, and x minus 1 equals 0. For the first one, we're going to add 5, so we get 3x equals 5. And then divide by 3, so we get x equals 5 over 3. And for the other one, we're going to add 1, so we get 1. Okay, last problem. G of x equals 16x squared minus 2x minus 5. So again, we're first going to do the x method. On the top is negative 80, and on the bottom is negative 2. The two numbers would be negative 10 and 8, and we have 16x on top of both. So for 16x over negative 10, we can simplify that to 8x over negative 5. And, and that becomes 8x minus 5. And 16x over 8, that simplifies to 2x over 1, which becomes 2x plus 1. Okay, so we have 8x minus 5 times 2x plus 1. That's our intercept form. And we're going to set it equal to 0, and that's how we can find the zeros. So 8x minus 5 equals 0, and 2x plus 1 equals 0. So we're going to add 5, and we get 8x equals 5, divide by 8, So x equals 5 over 8. And for the other one, we're going to subtract 1. So 2x equals negative 1. Divide by 2. And we get x equals negative 1 half. So the zeros would be 5 over 8 and negative 1 half. I'm just going to rewrite this comma. Okay, hopefully you can tell that's a comma. Okay, I will see you guys next time. Hopefully this video was helpful.